This is a Coast Division eClinic on using servos in model railroading.
Okay, so Fred and I are going to walk through servos. We talked a little bit a couple of weeks ago about them, and we got roped into doing a more deeper dive in that. Happy to do that. So I'm going to kick it off, kind of talk about what servos are. Fred's going to jump in and show some examples, and then I'll wrap it up with some more advanced Arduino-based stuff. Please feel free to ask questions as we go along, or hold them to the end. I'm fine either way. So what is a servo? And I have props. If you can look at the little video, and I can do this afterwards, they come in all different shapes and sizes. I've got little ones, and then there's big ones. So they're all types of different types of servos and sizes and strengths and all that. But what is a servo? It's basically a motor that's actually a closed loop mechanism. And so it has feedback in it, and I have another slide on that. But it's, in simple terms, a motor spins freely. A servo typically doesn't. It has a range of motion, and you can say, I want the servo or the position right here. The input is very simple. You got obviously your power, and then a control signal. And then you control it with a pulse width. Sounds complicated, but it really isn't. So what you basically have is you have your basic servo. It's got some gearing. And it has this feedback loop, and then you send in a signal, and it just does a comparison to make sure that they match. The output is compared through this simple comparator, and you know, by adjusting your pulse width, you go from a position. So think of it, your pulse width is really setting a degree, and then the faster you change the pulse width, the faster the comparator is going to apply more power to the motor. It's going to move quicker until it gets to where it needs to be. It's simple as that. And you know, basically your pulse width, a typical is 1.5 milliseconds. Sounds really complicated. It really isn't. There's a lot of products out there to help you do this simply. There are also another type of servo. They're continual rotation, and basically it takes out that resistor per se, or the potentiometer and comparator, and the pulse width actually turns the servo left or right, clockwise or counterclockwise, depending upon what your pulse width is, and then if you give like a 2 microsecond pulse width, it's kind of like neutral, saying, I'm going to stay exactly where I'm at. Most servos can be easily modified. I've modified a few to be continuous rotation. You take off 4 screws, you disconnect the servo, the resistor, you put the 4 screws back in, and now you're a continuous servo. And then, you have a different way of controlling motors and speed. The beauty about servos is low power, very easy, but high gear ratios, so a lot of power and torque with them. Okay, so how are they different? Well, DC motors or steppers, they spin free without limits. And stepper motors can hold the position, but you've got a lot of complex things you need to wire with them. That's outside the context of today's discussion. But the thing with motors is you have no positional information. You can maybe do an optical encoder to determine the RPMs, but you don't know really where the servo is or the motor arm is. With a servo, you always know exactly where it is. You know what pulse you're sending it, you know where it's at. And so with that, so what can you do with servos? So that's the basics of what a servo is, but what can you do with these things? A crossing gate. So you can automate, because it's a limited motion, you can control a gate up and down very easily. You can do wigwags, if you remember those. I've seen a couple of these where you can buy them as kit, or people have modified them themselves. I did a switch machine, a track switch machine. You can animate doors. A few years ago, I was at the narrow gauge convention up in Salt Lake, or yeah, I think not Salt Lake, Seattle, and somebody had used a servo to make a rocking chair. So it's just somebody on a rocking chair, and the servo was just moving the arm back and forth, and the chair was rocking. You can do it with figures too. So there's a lot of different ways you can use servos, because once again, it's a motor that you send a signal and tell it, which very simply tells it where to position itself at a slow rate, and then, you know, a lot of interesting things. So I'm going to turn it over to Fred and let Fred talk through some of his, what he's done with them.
Oh, good morning. Okay, I use a program offered by a company called POLOU, and they offer a free software program that you install on your computer, and you can get a servo and a control board and plug those in. And then there's a number of sliders on the first screen. There's a number of sliders you can, yeah, right up in there, right. And you can have them for each servo has its own control. So you can move the slider back and forth. I don't know if does mine show on that? No. Anyway, no matter. You can move it back and forth, and that operates the servo back and forth. If it's a continuous rotation servo, then the slider controls the speed at which the servo operates. So you can have, I think the smallest circuit board has 12 controlled 12 servos, and they go all the way up to 24 servos. Most of them are used for servos. There's a few that you might want to use for inputs or outputs, and we'll talk about that in a minute. Okay, the next slide, please, Jonathan. Okay, on the next slide on the program, you can give a name to each servo. On the left-hand side, you go like, they have them named here, left arm, right arm, so forth. You can define whether you want it to be a servo or whether you want it to be an output or an input. You can define how far you want the servo to operate back and forth. What you want it to do when you first start it up, how fast you want it to operate, and how much acceleration you want it to have. So all very useful. And as you can set up any number of screens like this. There's on the bottom left-hand side, the thing that says save frame. So you can plug in several servos. You can put them in different positions, save the frame, put them in another position, save the frame again, and continue to do that any number of times. The next screen, please. Jonathan. Next screen, please.
Yep. There we go.
Yeah, there we go. Then you can, so for each...
Jonathan was off doing chat there, Fred. He was answering lots of questions in chat, and he had to figure out how to get back to the Zoom screen. Sorry about that.
No problem.
By the way, for everybody, that's why we have a producer and a moderator. It's because it gets really hard to keep track of what you're doing on the computer when there are two different things on different screens you've got to do and kind of keep track of them. So back to you.
So for each time you save a frame, it creates another frame name. So you could have like a character that moved back and forth and another character moving back and forth, and you can set those up so that they can move in any sequence you want. And then you can name each frame, give each frame a name and define how long you want it to last. So there's a frame name and there's a duration for each one. And you can set up a whole sequence like this. As I say, I mean, it could be, I don't know how long it could go, but quite a long sequence if you wish. You can and this is how simple it is. There is no programming at all. You don't need to know anything about programming. I know practically nothing about programming, and I was able to do a fairly complex sequence of events. You can test it by pushing the play sequence button. You can rename it. You can set up different parameters for it. And then you can go in, in the top right-hand side, there's a button that says new sequence. And you can go into that and create as many additional sequences as you want. So you have a series of frames in each sequence, and then you can have a number of sequences. So the thing can get very, very complex if you wish it to. For most of what we would do, we'd probably, you'd probably have just a few sequences, but you never know. Now, if you want to go further with it and control it with an input or receive an output from it, then you can copy the sequence to the script, and that puts it into a programming mode. The company offers a very well-written manual on writing the programs. So if you wish to put them in a programming mode and operate it by inputs, that's available to you. Jonathon's gone quite a bit further with that part of it, and I'll let him cover that. Programming still is quite new to me and quite uncomfortable. So I do most of what I do with just the normal sequence without using the program. Jonathan, can we have the next slide, please? Here's a Cuckoo Clock that I made some years ago, and I'm showing it just so you can get an idea of, this has like 14 servos in it, and it's all run by just the basic program. There's no written program in it. Can you make it operate there, please?
Yep.
Thank you. So there's a cuckoo bird that comes out, and then a winch drops a load of lumber down. And this winch that's dropping the lumber down is a continuous rotation servo. So it drops it down. Now the servo starts, the other workers start to work in there. You can see people hammering and sawing in the window there. And this guy's planing a board. And then there's another guy over here, well, hanging onto the window, but another guy over here planing a board. And the guy in front cutting a board with a power saw. And there's music that's playing in the background. You can't hear it here, but there's music playing. And then the winch draws the wood back up into the window, and then the window closes. So this is all done with servos. I couldn't, for the life of me, figure out how to do this mechanically without servos. So this just shows some of the complexities that you can put into a device. So you can get very creative on a train layout this way. Could we have the next slide, please? One of the things I did, I wanted to experiment with just closing a traffic gate. And so I made a little model here of my layout. On my layout, I have 3/4 inch plywood covered with 2-inch foam. Then I mounted a traffic gate on top of it and a servo board down below it. And then right at the bottom of the screen, there's a little circuit board, and that's one of the smaller circuit boards, servo control boards. I think I said 12. I think it's 6 servos. Jonathan, do you remember? It's something like that.
Yeah, the one in this particular photo is a 6 servo controller.
Yeah,
They come in different sizes.
A 6. So you could, in this case, I had 2 traffic gates for each side of the road. So I used 2 channels for the 2 traffic gates. Then I used 2 channels for inputs. And so I was able to, on my computer program, I was able to just close the relay. And when the relay closes, it actuates the gate and draws it down. And then I actuate a second relay, and that causes the gate to come up. The next slide, please. Now here's a yeah, run it, please. Oh, here the train's approaching, so the traffic barrier goes down. I added some LEDs onto it to add a little flare to let it flash. The train passes through, and when it's done, when it's passed through, then the gate opens again. A fairly simple little program, but it shows one of the things that you can do with little servo motors. The same thing I saw on an article some years ago. It was printed where a guy had a bulletin board, and he had people applying a new bulletin onto this bulletin board with servo motors. So there's a lot of clever things I think you could do. I had one more. Jonathan, could you go to next slide, please? Here's a little entertainment area, and these are all run by servos. These are all continuous rotation servos, but each one has a separate servo, so you can run one ride a little bit, it can stop, it can run another ride a little bit, then another one can stop, so it can keep like the Ferris wheel. You notice it stops to let passengers off and on, and while the other ones are starting and stopping. And this is all done. There is no written program to this one at all. It's just a matter of operating those sliders, and then saving each step in this that you've set up. So those are some of the things I've done with servos, and I'll let Jonathan go into a little more depth in what he's doing.
Okay, so very similar. I had a box of, like I mentioned a couple weeks ago, a bunch of servos, and I'm starting my layout, and I wanted switch machines, and I've looked at commercial products like Tortoise and all that, but I was scratching my head saying, I've got all these servos. I'm not going to use them for model airplanes per se. What could I do with them? So I built, and this is my little test bed. I thought I'm going to, you can buy products that use servos for switch machines, but I'm going to build one just because. And so what I ended up doing is, unlike Fred, who used that servo control board, I used an Arduino. So if those who are familiar with Arduinos, they're just a little embedded programming that have actually a whole bunch of libraries for servos. And so what I wanted, and part of the other motivation, I had the servos, but all of the products didn't do what I wanted. I wanted an LED that would change colors based on the track, and then I wanted a simple wooden push button, and I push the button, it switches one way. I push the button, it switches the other. That's as simple as I wanted, and I wanted the LED to change colors. And then of course I wanted the slow motion. So I'll go through in a quick video here. Is you push the button, and then if you can watch closely, the track slowly moves, and then the LED is flashing saying it's changed directions and changes to red. Push it again and it goes back the other way. A very simple, all slow motion. It also takes advantage of my 3D printed, so I 3D printed the brackets to mount the servo and all that. Here's another view of the slow motion of the servo actually moving. I ultimately am going to hook up switch stands so the switch stand faces will actually turn. And so another reason why I wanted it to move nice and slow. Yes, you could do this with other products that are out there. I had the servos, and so I kind of wanted to use my servos. So let's talk about products. So this is the little board that Fred was using, the little Polo servo controller. It's very nice from the standpoint of you can hook up multiple servos, as Fred talked about. You can have inputs and outputs. You can set up your software. You don't need to know programming. You just use that interface and set that up on the board itself, and then it takes care of the rest for you. Here is a Walter switch machine that's servo-based. There's a lot of others out there. And then the Arduino is another way of doing this, and it's a little more advanced. Basically, what I ended up doing is, and they have a sample program. If you're familiar with any type of programming, it's really easy. You just give a command and say, I want the servo in this position, and the servo moves to that position. And an Arduino can, depending upon which flavor you get, you can hook up to like 16 servos to them. And so I wrote just a little bit of code that gave me my single push button and then track position. I also wanted to dabble in PC boards, so I made my own PC boards and put the Arduino on that just because I wanted to learn how to do that. So how do you get started? Well, you can get servos from anywhere, Amazon, eBay, your local hobby shop. You can get servos for about $1 a piece. So not a whole lot of investment. You can also buy servos that are hundreds of dollars, so a huge range. Most of the servos I'm using are, they're just cheapies, about $1 or $2 a pop. Then you need some type of controller. An Arduino is one. You can get one of those for about 13. Sorry, I was wrong. They can control about 12 servos. And then the servo controller that Fred was using, you can get the small one of that for around $10 off by Amazon or your favorite local store. And that's, so the investment to get started isn't that much. And, all of these controllers can handle more than one servo. So, it's something to think about. So, the question is, what can you dream up with servos? How you can use them. There's a lot of interesting things you can do with them. And with that, I haven't been following all the questions. I'll put a plug in. If there is interest in more advanced of using Arduinos or PC boards or things like that, I'd be happy to do another talk on, how did I go about laying out the PC board. The cost for doing PC boards is incredibly low now. You can get 5 PC boards for about $5. Sorry, $2. So 5 boards, $2. So the entry cost is not much these days.
Jonathan, you brought up an interesting point. I know. I think Seth and I don't know who else did a project a while back on Arduinos. I mean, it might be interesting to think about a clinic for us on that topic. Might also be an interesting topic for the summer. And one of the cool things is because these things are virtual now, you can actually share your screen when you actually go through the programming steps. I mean, so it might be interesting to show people how do you go find, code for an Arduino that's out on the internet? How do you load it? How do you put it in and go through the process? Because I think, for us, that would be a good project to understand what things are out there for railroaders in that space. And Seth, I know you did something like this a while back.
Yeah, I was just about to post the link to the project board, which actually had the very same grade crossing controller application that Jonathan described. I first learned about these when they, I think pretty early in this, like maybe 7-8 years ago. And not to take anything away from what Jonathan is saying, because it's, we're looking at the same reality. I heard about this. Dave Falkenberg and John Plocker did a clinic way back when we were meeting at Boucher's school. So that gives you guys an idea. And I saw this thing and my first thought was grade crossing controller. It just screams grade crossing controller. And anyway, so that was the application we did. I'd be happy to dust that out and do it again. Although frankly, this is great, but that was a little more of a hands-on. I'd
Right.
also be happy to do the CAD clinic again if you guys want.
You know, I'm kind of thinking, you know, that I think that was great because that's some focus, but it might be good to just have a conversation around, you know, what it's almost this confluence of things. It's that you can 3D print the stand now to mount the servo in, and if you need a specialized board for something, you can make a specialized board. And I'm wondering almost how do you bring those kind of three, it's almost like there are these things that used to all be unattainable that now are easily be obtainable. But when you bring the three together, it lets you do really interesting things. I mean, I thought the grandfather clock as a building on a layout would be brilliant. And Jonathon's now, he's showing us, here we go.
Yeah, there you go. So you know, here's my 3D parts that I printed. So that is the servo mount that the servo drops in. And then it's got the centering hole in it right now. Then this is my switch bracket. So if you look at my board, there's my switch bracket. Here's my servo piece. And then there's my PC board that I made. You know, it's a typical engineer. I went over the top. This board is a multitasker. It can be a switch machine, or I can use it to drive animation and lights for buildings and stuff like that. So, you know, great flexibility, and it's all DCC controlled. That was the other thing. I'm using NMRA and building up a bunch of automation code that, you know, I've got 2 wires that I run to all my buildings, you know, and control everything. But it's a combination of 3D printing parts as well as, you know, connecting it up. So.
Right. And it seems to me it's bringing together kind of all of these things, the low-cost servos that come out of the other spaces, the low-cost control systems, either specialized or servo-based, combined with 3D printing, and then the capability to do these easy computer programming for everything that's become so much easier. It's just, it's an interesting thing to bring those together to say how that those together change the hobby. And you don't have to do all of them, right? You can do the 3D printing and the servos and do like Jonathon did and do the simple programming. For automation of building, you know, that may be the best answer. So I think it'd be interesting to think about over the next few weeks. How do you package that up in a way to say, you know, this is kind of transformational? Because I think it is. I think the ability to print something physical and instantiate control with a servo run by a computer. I mean, the idea of being able to open the door and Jeff Bunza has been doing some clinics on Saturday afternoons at Jim Kello's New Tracks, where he's been showing some animation, the same thing. But it hasn't been, I don't think, as detailed as you guys have been about the way you can get the components to do that. And that would, I think, it's making it approachable.
Yeah, and you know, there's some questions in the chat about does a computer need to be connected? And the answer is no. You can absolutely, you know, set the scripts and things up that, you know, it takes input from like you know, little switches or whatnot and do it on its own. And so the having to have a computer not required to run it, obviously to program it and set it up initially, yes. And then on the PC boards, yes, JLC PCB is actually where I've been getting my orders for PC boards. And they've been running a special for, you know, 5 boards, $2, $10 shipping.
Well, and Seth, I think you also did a clinic on kind of using software to design how to design the boards.
Yeah. I did a clinic on eClinic once or twice, and again, that would lend itself very well, actually better, as you were talking in future planning, better to this format than in person.
See, yeah. I love kind of clinics like where you have, so I'd be great, Seth, for you to talk through maybe the programming and do a demonstration of the program, talk about it, and then Jonathon, maybe together, or Jonathon, you talk about how do you get boards made? You know, how do you find what's the process you have to go through after you've got the design done? You know, the 3D
that's just part of the clinic. Sure.
Right, exactly.
You know, and the good news is it's not very hard. Yep. You know, much like 3D printing has a stage at the back end called the slicer that takes the file and sends it to the printer. There's a thing called a Gerber file, which
Yep.
is, you know, the
Yep.
STL file of the PC board world.
Exactly.
And, you know, Eagle and KiCad, for that matter, have tools to modify the GURBs so that they deal with various manufacturers' processes. For example, I use a couple of Chinese suppliers, JLC and Seed, Seed with 3 E's. But some people use a guy up in Utah called Osh Park, who also does pretty good work. Kind of spendy, and the boards are a little crude, but anyway, you need to have a slightly different file to deal with them.
So guys, what I'd like to think about, and I'll make this a challenge to everybody on the coast. The way the summer program is going to work, there's going to be these 2 clinic rooms or clinic tracks, and they're going to be morning, afternoon, and evening. The morning are 3 clinics. If we suggested to Bruce, we'd like to do 3 clinics in a row, focused on the new technologies. So maybe one on 3D printing, one on boards, and one on kind of computer control of servos and other things, to kind of say, how can you use and kind of the idea is to, through those, think about how they relate. I think that could be a really interesting kind of block because I think there are a lot of modelers who like to use those things, but just don't know how to get started. And if we could make it so this is how you get started, this is how you do your first, you know, and for example, do something where the STL files get shared, links to the STL files, links to the Gerber file. Anyway, just think about it. And we've got time to do it, but I think it'd be a really interesting program. So
another thing to think about, and I've been pondering this. So I had, you know, when I was working, I taught a lot of classes, and we did hands-on classes. And, you know, and we did some of them you know, a couple of years ago through Zoom like this, where everybody had in their hands, you know, an Arduino or something like that. And then in a Zoom session, walk through together and say, write this piece of code. And we could do something more hands-on in a virtual format. So something to think about as well.
Yeah. The format really lends itself to that, because you can actually, you know, see the fine little vector graphics these programs are throwing up in a way you could never see on a big screen.
Exactly. Dave Gibbons has his hand up.
Yes. Well, first of all, the important thing, Seth, you realize that your head is blocking the locomotive in your backdrop.
Okay, Dave, points for where is it? Where am I?
I think you're in Canada. BC
That
Rail?
would be right, eh? Say again?
No, it's not BC Rail. It's somewhere near
Morant's Curve?
Morant's Curve. No, I'm just thinking more Revelstoke area.
A little east of there. It's on the Bow River in Banff National Park.
Right.
Okay. Now, to the less important point, the thing is, some of us, maybe not all of us, are cheap, pardon the language, bastards. And so for me, I sit there, and right now on my first phase of my switching layout, I have a toggle switch and a tortoise, and it moves the turnout, it powers the frog, and to switch over to going to servos and boards and some, I guess some of these cards can, the servo drivers can take an input from a toggle switch, but I still have to tell the servo somehow how far I need it to move. It seems like where, you know, cost benefit, where are we at?
They're cheap. I mean, Mark's board is a little bit high because of the way we make it, but it's got the pots on board. So the adjustments are there. All you need is a screwdriver. The Pololu one you do need, I think, to jack in with USB. If you look around on some of the usual Asian sources, you can probably find ones that are similar. But I mean, the point is that a tortoise today, if you buy it retail, is about 20 bucks, maybe 15. The servo, as John pointed out, you know, you buy them in a bag of 20, 2 of them will be bad, 18 are okay, so your unit cost is about $1.06. The bracket could be as simple as a scrap of of 3/4 inch angle, and the
Well,
controller sub $10, right?
I'm just like most of us, kind of cheap, and so I did the cost analysis because I don't think it's maybe cost advantage to say, hey, I have a layout and I have all these tortoises and I'm going to replace it. That's ridiculous. If it ain't broke, don't fix it. But in my case, I'm starting with nothing. And so I went through and said, well, I'm going to have about 20, 30, 40 switches at $20. It's like, ka-ching, that's a big chunk if you look at tortoises and all that. And so I did a back of the envelope paper type napkin. What would it cost me if I rolled my own? And I'm coming in at about $5 a switch. That includes the servo, the electronics, the cost of making the PC boards, because I'm buying in bulk. And so the cost dynamics are really low if you're starting from scratch.
But Jonathan, you didn't talk about the benefits that you're going to live a year longer because of all of the effort and thought you put in and stimulation you got of doing all that.
Exactly.
No,
Well,
there's one more advantage too, and that's that you can do far more complex operations with a servo board than you can with the others, and you can have 2 or 3 things operating simultaneously.
Right, and I solved a lot of problems in code just because, and so for like, how do you set the limits and all that? I came up with an algorithm where I put in the servo, I put it in programming mode. There's a button on my PC board that says programming mode. The servo moves to center. I connect the center pin wire, and then I push the button and it travels to the left. When it gets to the maximum I want to the left, I push it again. It goes to the right. When it gets to where I want, I push it again, and it's now all programmed. So I don't need a computer or anything. It's kind of like this self-tuning. And so I don't have any hand, special things I need to figure out. I just look and push the button.
Hey, Jonathan, do you put are you putting your 3D designs for your components up on Thingiverse?
I should. It's on my to-do list.
Let me ask a question of everyone. So of the folks that have started doing this, there are places where people put things. So generally, if the 3D world stuff goes up on Thingiverse, I'm assuming that in the printed circuit board, there's a place for that. For code, there's a couple of code repositories. So we've been having a conversation on a separate conversation. Fred put some stuff together about trying to create a local resource file. I'm kind of wondering, is this something that the NMRA should be considering putting together a repository for model railroaders of different types of, so Jonathan, instead of putting them up, because the reality is a model railroad switch machine controller printout for a servo has no interest to anybody but model railroads. So putting up in the general Thingiverse thing just means model railroads have to go there to find it. If we created something that said, here are 3D prints for model railroading, here are circuit boards for model railroading, here's code that people wrote for specific things for model railroading for different, whether it's a Raspberry Pi or an Arduino, is that a value that the NMRA should really be considering to bring to members? Because one of the things that strikes me is that we're always questioning where the values are. That could be a huge value for all of us.
Well, Phil, what they
Definitely.
what you could do is have a page of links. For example, almost all of my stuff is.
I don't want links. No, I want.
No. It's got to be links, Phil. It's got to be links.
Why can't we create a repository like
Thingiverse? Because you'll end up with multiple copies of the source. Almost everybody who's serious about this has a GitHub page. I do, for example. And almost all the stuff on my site is linked to my GitHub page. Now, what that means is that if you use GitHub and I make a change, that propagates to your copy. So you automatically, you click a button and you update. If I have multiple sources, and I'm not going to put my stuff on NMRAs, I'm going to put it on my GitHub, and most people will do that also. So link to my GitHub, link to John's GitHub. And
the challenge is that links aren't searchable. So the problem is,
but you can do search, Phil. You can search within page.
No, I understand.
I mean, that's what works. Now, I'll make an offer to everybody here. If you have an idea you want to share and you don't really want to be in the business of, dealing with shipping and sales tax and all that crap, most of my stuff is contributed. And, contact me offline. We can put this up. I've done a number of things like the Keep Alives, which are, just club projects in my mind. But we can offer that.
Right.
Again, I'll place
cool.
that stuff on my GitHub if you don't want to be bothered.
So Seth, how would if we came up with a specific tag, like model railroad or something that was the tag that you put on things that you put on GitHub that were related. So what I'm trying to do is for example, when I go to Thingiverse, I have to try to find Jonathan's switch machine parts that he put on Thingiverse, just like somebody who comes to GitHub has to find your code block. And so it might be interesting to think about how do you put some tags on those when you store them in those tools, because generally there's a place to put tag fields. And if we could put tags on things, so now what we can have is we can explain when you got a link that says, here's GitHub. When you get to GitHub, search on these fields to find model railroad projects and these kind of tags. So
I believe they already exist, Phil. There's a thing called an info file, which is a fairly standard GitHub designator that does have a tag field. And I share my tags with John Plocker as a site called SP Coast, which I strongly recommend. And I'll paste both of those into the chat. We share those so that, you can find either of our stuff and we don't have to have, again, 2 copies and things getting out of sync.
Right.
So there are good tools for that.
Well, to me, what's missing, because I spent a lot of time, when I was doing the servo controller, looking for what's out there, because I didn't want to have to write something if I didn't have to. And what's really missing is consistency of how to search for things. Right. And I totally agree with, you don't want to have multiple copies. There's, GitHub and Thingiverse and all that. But where I think our group or the NMRA can do a better job is coming up with a set of standards of how to tag things. Because right now, you try to search for switch machine and it's challenging to say the least.
Right. I think creating a set of tags, that's an offline subject we'll take. So any other questions on servos? Let's get back to servos.
Yeah.
Any other questions, comments? I went and looked on Amazon and I found, I think it was 10 for $17.99 as Amazon's best rated. So that's $1.80 each.
Yeah. The prices changes all the time. eBay, you can find them on eBay.
Well, I'm sure you can get them cheaper, but that's kind of the easy way to go find them, and it's kind of reliable, and they come in 2 days. So.
Right.
Cool. Well, with that, we'll jump on, and thanks, Jonathan and Fred. Really appreciate that. I think it's great. It's an interesting thought, says a lot of us complain about not having room to do the modeling we want to do. And I think automation is an interesting way to do more modeling in the room you have. It becomes a really interesting project to think about, that depot you built 5 years ago, 10 years ago. What if you made it so the door of the depot would open and the freight attendant would come out and then go back in and the door would close? So how would you do that? And that becomes a really interesting project. So, and clearly you've got some experts you can query on that if you need help.